today we are looking at the intersection of lines. Last time we looked at the equation of a straight line, how to find the equation of a straight line from our previous knowledge of finding the gradient. We move on to the equation of a straight line. Now from equation of a straight line, today we are going to look at intersection of lines, when two lines intersect. When two lines intersect, and we are asked to find the point of intersection, how do we go about it? And we are saying that if two lines intersect, the coordinates of the point of intersection, the coordinate of the point of intersection must satisfy both equations. So if two lines intersect, the coordinates of the point of intersection must satisfy both equations. Now, how do we analyze this? The coordinates of the point of intersection of any two lines is the same as the solution of the two equations simultaneously. Okay, so what we are basically saying is that when the equation of two lines are given and we are asked to find their point of intersection, and we are asked to find their point of intersection, we are saying that the coordinates of the point of intersection of any two straight lines is the same as the solution of the two equations simultaneously. Let me take this one again. If two lines intersect, the coordinates of the point of intersection must satisfy both equations. The coordinates of the point of intersection of any two straight lines is the same as the solution of the two equations simultaneously. So if you look at this side, we could see that we have two lines over here. We have the first line, let's say line AB. Then we have line CD over here. Now, if you look at these two lines, we have the equation of line AB. The equation over here is y equals 3x minus 5. And with the line CD, the equation over here is y equals 4 minus 5x. Now you can see that the two lines meet or intersect at the point P. At the point P. The two lines intersect at point P. Now the question is, how do we find the coordinates of the point P over here? So the intersection point, how do we find the coordinate of P? That's what we are talking about. And we are saying that to find the coordinates of point P, what we have to do is to solve the two equations simultaneously, as it was indicated. So the coordinates of the point of intersection of any two straight lines is the same as the solution of the two equations simultaneously. So we have to solve the two equations simultaneously. And the values that we are going to get for y and x will represent our point of intersection. And take note, this point that we are going to get is going to satisfy both equations. They are going to satisfy both equations. So basically, whenever we are asked to find the intersection of two lines, the point of intersection, what we have to do is we have to take the two equations that will be given to us, then we solve the two equations simultaneously. And we know how to solve simultaneous equations, right? Good. We can use either elimination method, we can choose to use the substitution method. So from here, now our two equations have been given, which is this one and this. So for me to find the point of intersection, which is P, what we have to do basically is to solve the two equations simultaneously. So let's try and solve the two equations simultaneously. So we have our first equation over here. So let's have our first equation, which is y equals equation 1 over here. Then the second equation we have this becomes our equation 2. So what do we do over here? We solve the two equations simultaneously. But here we see y is equals to this. And the second equation too, we have y is equals to this. So here we have y being the 7. So what we do is, we do the substitution, right? So let's use the substitution method. So if y is equals to this, and y is also equals to this. So in place of one of the y's, we can put that inside. So we are going to have, let's put equation 1 inside equation 2. So we are going to have 3x. So in place of y, we are putting these values here. In place of y. So we have 3x minus 5, okay, equals 4 minus 5x. So we are doing substitution. Y is equal to 3x minus 5. Y is equal to 4 minus 5x. So what we do is that this is y, this is y. So we are putting equation 1 inside equation 2. So we take this value, in place of this one, we can put this value inside here. And that's what we are doing. Someone can say, why not this one? We can also choose to take this one and put it over here. Because it's still y. Okay. Then you have your nice equation. You're going to get the same thing if you use that one. So this is what we have. Then we solve for our x. So we group like terms. We can bring our 5x over here. We have 3x plus 5x to be equals to, this 4 is already there. Okay. Send your minus 5 to the other side. We have plus 5. Over here we are going to get 8x, right, equals 9. Then we divide this up by 8, here by 8. This will cancel this one off. Our x is equals to 9 on 8. This is the value of our x. So getting this, we can find our y. Any of the equation, we can use any of the equation to find our y. So we can find, taking equation 2, we have y to be equals to 4 minus 5x. Okay. So y to be equals to wherever we see x. This is x. So we are looking, we got x to be 9 on 8. So in place of x, we put 9 on 8 over there. Okay. Then we can simplify this one nicely. So here we have y to be equals to 4. So you see our minus 5 is multiplying 9 and 8. So we multiply by the 9. Okay. So you are going to have minus 45 on 8. Okay, then we simplify further. So we are going to have y to be equals to. So over here, you can see that 8 times 4 minus 45 out of 8. I hope you can see that. Or better still, divide this out by 1. Then you find the LCM. Then you simplify. Okay, find the LCM. So 8 times 4 minus 45. Okay, all out of 8. That's what we're going to have. And 8 times 4 is going to give us 32. Minus 45 out of 8. Okay. And this one is going to give us y to be equals to minus 13 on 8, right? Minus 13 on 8 for our y value. So in this case, the coordinates of the point of intersection P, okay, in this case, so the point of intersection P, the coordinates are our x is equal to 9 on 8, and our y is equal to negative 13 on 8. So in this case, you can put them nicely this way. So our point P equals 9 on 8 and minus 13 on 8. So basically, this is what we are getting. So the point of intersection of these two lines, okay, the point of intersection of these two lines, which is P, point P, has been given us 9 on 8 minus 13 on 8. So after solution, this is what we are getting. So basically, what you have to do is, whenever you are given two equations to find the point of intersection, in short, the only thing you have to do is to solve the two equations simultaneously. Okay, solve them simultaneously, either by elimination, by substitution, but I prefer substitution because it works at all angles. Okay, so that's what we are getting. Let's take a similar example and look at it again. So this is our second example. So find the point of intersection between the following lines. So we have 2x plus y minus 3 equals 0 and x minus 3y plus 4 equals 0. Then we have the second part, which is y equals 2x minus 9 and 4x minus 7y plus 5 equals 0. So with the same approach, let's use the same approach from the first example to solve this one. So let's take the first one. So we have to solve, the step we should find the point of intersection. It simply means we have to solve the two equations simultaneously and find the values of x and y. So here, we can indicate them, 2x plus y minus 3 equals 0 to be our equation 1. Okay. Then we have x minus 3y equals 0, equation 2. Okay. So from equation 2, we can make x the subject from equation 2. So we use substitution method. So from equation 2, x is equals to 3y minus 4, right? From equation 2. So here we are making x the subject, so we send these two to the other side of the equation. So we put these values inside equation 1. Wherever we see x, we put the values of x over here. So here we are going to have 2 multiplying 3y minus 4 plus y minus 3 equals 0, right? So here we expand the bracket. So we are going to have 6y minus 8 plus y minus 3 equals 0. So what do we do here? We group like 10. So let's send the constants to the other side of the equation. Better still, we can add them. So minus 8 minus 3 is going to give us minus 11, right? Minus 11. So when minus 11 goes to the other side, it becomes positive. Then we have 6y plus y, which will give us 7y, right? Equals minus 11 cross to the other side, we have positive 11. So we divide this up by 7 here, here by 7. 7 will cancel 7. Our y is equals to 11 on 7. So this is our y. So we can find our x over here. Here, x is already the subject over here. So we, in place of y, we put the value of y inside wherever we see y in x equation. So here we have x equals to 3 multiplying 11 on 7 minus 4. Okay. So here we do our multiplication. 3 times 11 will give us 33. 33 on 7 minus 4. So we are going to have 33 on 7 minus 4 over here. So we simplify this one, the same approach from our example 1. So here either we multiply this one by the 4. So 7 times 4 give us 21. 28. Then we subtract our 28 from 33. Okay? Or better still, if you have a problem with that, you can divide this out by 1. So that 7 and 1, you find the LCM, then you follow the approach. So 7 times 4 give us 28. So we are going to have our x to be equals to 33 minus 28 all on 7. And this means our x is going to be 5 on 7. Okay, 5 on 7. So it means the point of intersection of this first system of equation is we are going to have x value is 5 on 7, comma, and our y value is 11 on 7. So we add our 11 on solving to it. And this becomes the point of intersection of the lines 2x plus y minus 3 equals 0 and x minus 3y plus 4 equals 0. I hope with this approach you can try your hand on the second one. Okay, this second example, you can try your hands on it. After trying this one, then you have your program of the day. You have the program of the day. This is your exercise. So the first part, find the intersection of the line 2y plus 3x equals 16 and 7y equals 2x plus 6. Hence, find the equation of the line through this point with gradient -2. Yeah, I hope you remember that before we came here, we did the equation of a straight line. How to find the equation of a straight line when the point and the gradient is given. So you use the same approach to solve this particular problem. Then the second part, you have find the point of intersection of the line 2x minus 3y equals 8 and 3x plus 4y plus 5 equals 0. And I hope these questions won't be a problem. Okay. So this is it for today. Next time when we meet, we are going to look at parallel and perpendicular lines. And I hope you enjoy that lesson too. Thank you.